Hello, hello guys. Is my voice is audible? Yeah. Sorry for taking a long time. Okay. Now let's welcome. First of all, I welcome you all guys for the day two session of Step into Arduino. And let's. I want to just recap for 1 minute like what we have done yesterday. And we have seen like what is Arduino. It's open source one, and what we can do with Arduino, these sort of things, and how Arduino works, like what is the it's microcontroller and software. Now we go on to microprocessor and microcontroller, and types of Arduino boards. We have discussed about what are the types and where it is used. And next we go on for Arduino, how the memory allocation takes place and what is a block diagram. Then now I will start with Arduino Uno in detail. Like first, before jumping into the coding, I want to explain how to connect the pins. Like we can learn coding is not a big issue, but we have to learn how to connect the things and how we can program. First thing, before not hopping into the program, I will say how to connect and what are the paths in Arduino Uno. Okay. First thing, USB. Can anybody define, like, just give the abbreviation of USB, full form of USB? Hello? Yeah, absolutely correct. Like universal serial bus. It's like yesterday I think I have discussed about this USB. Can anybody say what is it used for? Yeah, when we are using a microcontroller board, this is Arduino Uno board, and we have to where we program in Arduino IDE, that is in our computer. So if we want to send the instructions or the code to the Uno, we use universal serial bus, that is USB, to transfer the data in a serial way, and also uh, for power supply. You can just see like here data transfer is there. You can also you receive and transmit the data, and also power. It powers the Arduino as well as transmit the data. The data transfer takes place as parallelly power supply also takes place. And next I go for barrel jack. Barrel jack, anybody guess what is a barrel jack? If you are aware of Arduino, Yeah, okay, I will explain. USB only takes 5 volts DC current. Okay, it's DC, but what happens if I give AC? So it's not possible with USB because USB supports only DC current. So if I want to power Arduino Uno by like with AC current, that is alternating current. So I use barrel jack. So what is alternating current? So I want definition from you guys. Alternating current. Hello, is my voice is audible? Yeah, that's the thing. It alters with the time. Like it's not constant. When it's the DC is direct current, it does not it is not alternating current. Means what is alternating current means it alters time to time. That's the thing. It may be altering in a different way, like sinusoidal wave or whatever the wave it may be. So it's AC. It's alter with the time. Next thing, voltage regulator. Why there is voltage regulator? Because sometimes we make give more than 5 volts to Arduino Uno. Can anybody say what if I give more than 5 volts to the Arduino Uno? Yeah, it burns, but sometimes we the power fluctuations happens, and the more than 5 volts power can be what you say given output from the computer or some other device. other power supplying device. So what Arduino company did is like they set up a voltage regulator, so it can regulate the voltage up to 9 volts. You can give the power supply to the Arduino and up to 9 volts, but it only takes 5 volts. The excess amount of energy, that is the voltage, will be converted into heat energy. So it will be converted into heat energy and it will be emitted from voltage regulator to the surroundings. So that is why it is being somewhat placed at a distance from other components. So this is the reason, because it emits heat. So that is the reason it is just somewhat isolated from all these old equipments. Okay. Next thing, crystal oscillator. Or what is oscillator? Oscillator is like oscillating between two ends. It's like periodic motion. Uh, I think you guys know about what is periodic motion and what is oscillations, because you studied from the 11th and 12th and also in first sem in physics if you are from physics cycle. Okay, oscillation means it's a periodic motion and a periodic motion between two points. And what is the need of oscillator in Arduino? Means here we use crystal oscillator that in Arduino, it oscillates around 16 million times. That is 16 million times per second. That is quartz crystal will oscillate 16 million times. What is it used? Because we are uh, when we are doing with Arduino, we use delay functions. Like we set up some timing. Suppose I take LED. After 1 second, it has to glow. After 1 second, it has to off. So how can Arduino measure the time? How can Arduino know about the time? That is that function. The time will be set by this crystal, the oscillating crystal, the clock. Okay. Next thing is like reset pin and reset button. Suppose I want to reset, okay, I powered the Arduino but I want to reset from the starting. Whatever the program is running, I want to reset from total starting. I want to start a loop from start. So how can I do? One thing, I can use this reset button. I can use this reset button, and I can use this reset pin. I can connect to digital pin and I program. This is programmable one, and this is like physical button. This is use of reset button. And digital pins. What is the term digital means? Hello guys, can anybody say what is the term digital means? Digits, like digital, there are two types of pins. One is digital pins, another is analog pins. So here there are analog pins, this is a set of digital pins. What is the difference? Digital pin, it's 1 or 0, that is digital. It's a just the wave will be if the signal is like 0 or only 1. That's the thing. 0 or 1, it transferred the whatever data in form of binary, that is 1 or 0 machine language, because whatever the data is transferred here will be transferred in the form of binary 1 0 1 0, or this is the things. And whatever the data coming from this microcontroller after processing, the output will be also in a binary form output. So digital pins will be used for both input and output pins. Like these are programmable pins. You can program that using Arduino You can turn on these pins, you can turn off, you can set to high state, you can set to low state, entirely using programming. So digital pins means both used for input and output. There is a reason for there is a reason because whatever the data which is being processed in microcontroller, and it will be given output in the form of binary, because our machine, the computers only understand a binary code. So when it is reading, that's not an issue, but when it is giving the output, it only gives in binary, that is 1 or 0. Okay, so that is why, so digital pins, okay, it's giving in binary and taking in binary, so there's a no issue, and digital pin will work out for both input and output. Okay, next there is analog pins. There are 6 analog pins and 14 digital pins. Analog pins, what are the use? Suppose if I want use a sensor. Best example, like yesterday onwards we are talking about temperature sensor and making weather application or temperature app, Android app, all the things. So what a temperature sensor does, temperature sensor will take the input from the surroundings and converts and transfer it to the Arduino Uno. So what is the data will be given input to Arduino Uno, that will be in the form of numbers. It is ranges from some a set of values of just like A and B. Okay, this will be intermediate values. So temperature varies, like it is not just 0 or 1, not just 1 or 0. So it varies. So that is 1 minute. Just erase sync. Okay, that is only 1 or 0 if it's binary, but temperature sensor does not provide 1 or 0. There is different values, different intermediate values. So that is the reason we use analog pins as input. So whatever the input we give, that will be processed by here and converts into binary code. So that is why analog pins are used for input purpose. Yeah, okay, hope you guys are understanding what I'm saying. Yeah, hello. Yeah, which one? These all the, yeah, still I will name that. There are so many parts to name. That's the thing. Okay, you understand analog input, no? Analog input pins. Yeah, okay. Uh, Now let's go for another what is another type of pins. Okay, you know guys, what is 8 mega 328 microcontroller? This is the brain of the microcontroller board. What is the memory and what is the processing speed, everything will be in this thing. Can anybody talk for a few minutes what is a microcontroller and 8 mega, just to recap the concepts? Okay, what is 8 mega? Like at mega, yesterday Shreya discussed about what is at mega and what is atmel and what is microcontroller and what is a microprocessor. Yeah, okay, perfect. Okay, thank you guys, thank you for your response. I want the session to be more interactive because this is theory. I know it will be somewhat boring, and once it's done we'll go into programming. That is why I'm trying to make session interactive. Next thing, ICSP pins. There are ICSP pins. This is I in circuit serial programming. Full form is in circuit serial programming. Means first thing I want to divide this one. What in circuit serial programming? Serial programming means the data will be transferred in a serial way. Is programmed in a serial way. What is in circuit means? In circuit, that is okay. If I want to use one Arduino board, it's okay. If I want to use another Arduino board, I have to take the separate USB cable and connect to laptop. And I think that is not a good what you say, uh, good option we have. So we can go for other thing. We can use of ICSP pins. We can connect to the ICSP pins of other Arduino. Okay, and we can serially program that Arduino also. And with that, we can power that Arduino. We can program that Arduino using ICSP pins. Okay, okay, 1 minute. And these are other things are like just old what is it powering pins, because Arduino uses it for so many things. It may be used for powering the other components, or giving signals to the components, so that there are some uh, so many different types of things, like it may be capacitors or everything. So it is impossible to discuss now and go in deep, because like it will be so confusing for you guys if I discuss everything what are in the board. So I'm just giving only limited of the components what in code in the board. So that's the thing. Just here LED. If you this is LED, which is inbuilt one. So every Arduino board, every Arduino Uno board comes with an inbuilt LED that is connected to 13th pin. You can program the LED using 13th pin on or off. If you guys don't have LED at the time, and you want to write the LED program. So what can you do? You can use of this internal LED which you can program, which is connected to 13th digital pin. Okay, and you can see this TX and RX. Like if you connect to the sensor, if suppose ultrasonic sensor, if you don't understand, not an issue. We will discuss about ultrasonic sensor in clear manner. Firstly, TX. TX is transmitting. When the data is transmitting, this TX LED will blink, and when the data is receiving, then this RX pin will be blink, start blinking. And this is another LED on Arduino Uno, which is used for what you say, when you power on the Arduino board, then this LED will turn on, which is signifying that your Arduino Uno is powered. Yeah, okay. And you know about what is ground, what is 5 volts, it is voltage. And VIN is whole 9 volts pin. Like if you these are all power pins, reset pins, and input output reference, and analog reference. So these all the things are reference, and I don't want to go in deep in that concepts, so it will be so confusing at now, because it consists of more electronic based theory part. So that's why. And other things are used, what are the other pins are used for taking an input and output or connecting to boards. Okay, yeah, okay. Yeah, this is the reason why I'm not explaining each and every part of Arduino, because it will be so confusing for you guys for in the starting. Yeah, okay. Now let's go into the programming. And before programming, I want to explain. We are first program. I want to do LED. So when I'm programming, you guys don't do the programming. Just listen what I'm saying. Then this session is recorded in YouTube. Uh, so you can go ahead and you can check if you have any doubts. Now just listen what I'm saying, and concentrate on the line to line where I'm programming and how to program. Because if you start doing parallelly with me, it will be somewhat confusing. Like you may miss some concepts what I'm saying. So this is the reason. Okay. Yeah. Is my voice is fine? It's everything is fine from my end. Yeah. Am I going too fast? Yeah. Okay. Yeah. Thank you for response. And what is LED? I think from the what you say, from the school time onwards, you are hearing this word LED, LED, LED. Sometimes you can, some of you guys can have already played with LED also. So what exactly is LED? Yeah, it's a diode. Can you full form? Yeah, Yeah, it's perfect. It's a light emitting diode and connected in forward bias. And I don't want to go in deep because you guys know what is LED and how it's connected. You have studied for in 11th and 12. Is it okay? Yeah, okay. This LED. Now let's go and program the LED. And before programming, I just want to say one thing. Just consider this is LED. This is this is LED in circuit. So just remember the voltage drop across the LED is 1.8 volts. That's the thing. This is a thing I want to say that in theory part of LED. And now I'll go into the programming and I will explain what does LED really mean and how to program that one. Minute, give me some time. Because we are using Tinkercad software because the programming of Arduino in reality does not possible. So we are simulating the programming and using Tinkercad version. Okay, this is the software I'm using here, Tinkercad. Use it for CAD softwares, and it is a family from AutoCAD. So just open Tinkercad and sign up the account, and later you sign in and go to the circuits. So just take 5 minutes for sign up. Just everybody go to Tinkercad in Google and sign up in there. Yeah, now because like if you face any issues, we are there here to solve that one. It's no not really. Start tinkering. Its sign up is completed for everyone. Did everybody sign up? Yeah, okay. No, just tinker, just tinker. Yeah, which one? Yes, just do sign in. Just sign into the account after sign up, and just keep it out. Just close that one and listen what I'm saying here. I will show how to start the thing and everything, how to proceed. Yeah, okay. Can I start? Yeah, once once you open tinkercad, you have to go your dashboard will be open. Once you go to dashboard, here you can have your class, these all the things, join the class, all the things. So here go to circuits. So when you go to circuits, you can have create a new circuit, and just click on that one. So the new circuit, the blank empty what is a canvas will be created, so you can uh, tinker the what is it tinker whatever the circuit, and you can do whatever the circuit you want here. Okay, just I want to introduce you guys like what is tinkercad and everything. Tinkercad is a software from AutoCAD family. It is used for simulation. Like we can code here, we can start building the circuit, and we can uh, what you say, we can build a circuit, and we can connect the components, and we can run, and we can use serial monitor whatever we are doing for the maximum what you say things in the real thing using real Arduino we can use here. So you can see the left right corner is it search, and you can see all equipments. This is basic components is selected by default. If you want to see the all components, then click on all, and you can see the all the components, and it is categorized input, and you have so many sensor, flex sensor, force sensor, ultrasonic sensor, and these all things, and output. So it's very good software to use for simulation in this pandemic mode, because taking Arduino board and doing it's not practically not possible. So here if you want you can search for anything like LED, it will go, or breadboard, and this is how the search works. And the code is like we haven't dragged and dropped any microcontroller or anything, so it's showing empty. And start simulation and share, and these are the things I will explain. First thing, I will explain how to do a program LED to blink for 1 second. Once it has to time delay of 1 second, and it has to on and off. So for that, first thing to program that one, I need the brain, the main thing, that is Arduino. So we can just drag and drop here. You can see Arduino clearly, and these are analog pins, power pins, and this is microcontroller, and these are digital pins. So let's go and program. Now okay, we now we okay, we take an Arduino, and we have a code terminal here, and just it will be selected blocks by default. So go ahead and click on text and continue. So this is your code terminal, your IDE is ready, and microcontroller is ready. Now we need external component, that is what we are using, LED. So just search for LED, drag and drop here. And if if I just go ahead on the LED, like if I mouse hover on the LED, it is showing that it is cathode and this is anode. Okay, cathode is like a negative terminal, and anode is a positive terminal. Okay, now just I want to click on here, so a new wire will be generated. So I can just click, I get to turn. So I want to connect to 6th pin, just I can click. If I want to turn the wire, I just left click on the mouse. So if I want to change the color, I can go here, and I can just keep yellow, red, or blue, or anything. Orange will be maximum used for signal or data transfer. And this is an oh, sorry, anode. The positive will be connected to the digital pin, because a digital pin will have 5 volts in each each of the pin, it supplies 5 volts of the voltage, and anode pin is positive, it will be connected to the positive terminal, and cathode is negative, so it is connected to the ground. So if the current has to flow, there should be a potential difference. So there's a potential difference of here 5 volts and ground. So there's a potential difference. So current flows and LED glows. So first thing, before just directly coding here, I just want to run directly. Here there is 13 output, and you can see that LED is blinking. If you don't understand the code, no problem. I will just go by step. Now I'm just showing there is inbuilt LED. We can just program here. Okay, now when we are coding, this is electronic part, we use embedded C programming. What is embedded C? How it is different from embedded, what you say, normal C programming or normal C++, all the things is like when we're using embedded systems, when we're using dealing with electronics, we need to code a lot. So what they have done in embedded, they shorted and given more inbuilt function which can let us move so creatively. We can it reduce our job in coding so many lines. Okay, now first thing we need to say that we need to say Arduino we have connected LED at 6th pin. So for that we have one function void setup to set up everything, because starting Arduino don't know where we have connected or where we have connected LED and which pin it has to initialize. So we have to program that one and say we have to say that to the what you said we have to say to the Arduino, okay, we are I have connected to 6th pin, so initialize the 6th pin or allow 6th pin to program. So 6th, and I want to say what type of pin is it? There are two types, input or output. Can you know what LED is actually? Is input or output? Output, yeah. So as syntax says, it's output. Okay, just this is an inbuilt function pin mode, like we are just saying to Arduino like initialize 6th pin and which gives an output. So I had to receive the signal, uh, I have to receive the signal from the microcontroller to the 6th pin. That is, I'm say I want output data. I want to what data should be transferred from the microcontroller to the LED. Guys, 1 minute. Sorry, guys. Is my voice is audible? Yeah, sorry, call came, so that's why it's interrupting for a long time. Okay, void pin mode. Okay, we said like we are giving 60 pin as output, and we can define this in another thing. I don't want to use numbers, so why I have to use confuse the programming in using numbers? So I can just use LED, and LED is equal to int LED. It is just like C programming. LED is equal to 6. That's the thing. As as you guys have attended dive into C programming, so you know like how to initialize the variables. So we can use a variable, I declare it globally, so I can use them in my code. So just I can replace all the 6 with LED. So just I'm only playing with Arduino, so I'm just closing setup, and setup is completed. And ground, no need to, ground is like every time it will be 0 volts only, so no need to set up everything. Ground will be activated by default. Now there's another function called void loop. Loop suggests, it's like what is mean by loop? Yeah, I'm not saying about technical thing, just say what is the meaning of loop. Like repeated. Yeah, yeah, it trades for infinite amount of time. Just in the loop means it goes, it will continuously repeat the task. Whatever the task, it repeats for infinite times. That is in the loop. Okay, here I gone into the loop. Means whatever I type inside this thing, inside the loop function, it will run for infinite amount of time. It loops after iteration. It goes after one iteration to other iteration. Okay, first, okay, now I have to write these things. Suppose here sixth pin is there. Okay, if we have just said it gives output to the Arduino board. So how to program? So here digital write, we have to write the thing. Digital write LED comma high. Okay, means what does it shows? We are writing a digital pin write. This is in function and it takes two parameters. That is first thing which pin and the next thing what is its state. We are setting LED, that is LED sixth pin to high state, writing the pin number 6 to high stage. That will be the signals will come from here and it set the 6th pin to high state. So if the what is it, if the state is high, that is high means it's 1 1 0. I said no, it's like digital pins are only 1 and 0, means if the digital pin is getting 1 as input, like it's getting 1 as power supply, 1 as signal from the microcontroller, what does it mean? It's power on the LED, so it will glow. Yeah, hello, hello. Yeah, any doubt? Yeah, okay. Yeah, okay, okay. Now I just want to start simulation. Once you coded everything, just start simulation. So if you start simulation, sorry, and you can see that its LED is glowing. You can just, if I click on the code, it will just the window will close. You can see here LED is glowing, but I'm getting a issue. Like the current through the LED is more. It should be 20 milliamps only. So we have to take a resistor. So just stop on the simulation because excess current is flowing. As we are using Tinkercad, it's fine. It's saying like you are giving an excess current. So if we are doing a real thing, it may have a chance to burn off LED. So thanks to Tinkercad. Now let's see. Let's search for resistor. Okay, now I'm taking resistor. So here it's saying like how much resistance it has to take, it has to give. So just I want to go and delete this thing. I will connect here and I will just connect to here. Okay, this is a way the resistor can be connected to LED, but how can I know how much amount of resistance I have to give? Is any way to calculate that one? Yeah guys, yeah, perfectly right. I want to go here, 1 minute. Here LED. So let's give me a minute. One minute. Why it's coming in the middle? Okay, leave it, leave it. Sorry guys, I'm using Paint 3D, so it's okay. Is my screen is visible? Yeah. Generally, just take the circuit. This is, and just this is the internal circuit, and just we have to focus on these two components. This is LED and this is resistor. So we have already said that LED, there is a dropout voltage of 1.8 volts. So whatever the voltage will be given from the what digital pin, that is 5 volts. Out of that, LED takes 1.5 volts. So what is the remaining voltage? That is 5 minus 1.8, that is 3.2 volts. Is it correct? Yeah. If just I'm making so simplified. A to B, and the volt potential difference between is 5 volts. So if the potential difference is 5 volts, and if it takes 1.5, the remaining all energy has to be taken by resistor. So that will be, sorry, so this is 1.8, 3.2. So if you sum those, it will get 5 volts. Yeah, okay. So now we have to calculate what is the resistance. So what is the resistance? So 25 milliampere is the current which is received for LED. Okay, if it's 25 milliampere, sometimes in Tinkercad it shows 20 milliamperes. So as in Tinkercad it's showing 20 milliamperes. Let's go with it, and we have voltage of 3.2 volts. Okay, as it connected in series, the current supply will not change, so it is 20 milliampere and 3.4 ohms, that is for resistor. Okay, now I want to calculate what is the resistance. Is there any relation between potential difference, current, and resistance? Yeah, X V is equal to IR. That is Ohm's law, and R is constant. So if I want to find R, that is V by I. Okay, what is V? 3.2 by divided by 20 milliamps. So that is 10 power 3. Is okay? 10 power minus, yeah, 10 power minus 3. So 3 by 2 by 20 into 10 cube. Yeah. So once you calculate this, what you'll get? Just we cancel this 2, and this will be 1.65. Correct? It will be 165 ohms. Oh, sorry. Yeah, 160. It's 160 ohms. So just let's go for, we have find a resistance. Let's go here and let's make it as ohms and 160. Okay. Now if I turn on, you can see there's no indication like you getting more current. But when you are doing in real life, when you're actually coding LED, you don't use 160 volts. If you go to any tutorial or any anybody explaining a YouTube video, they just use 220 ohms. Can anybody say why? Yeah, but that does not actual reason. Yeah, yeah, it's yeah, it's correct. It's 100 and it's around 220, and these are the standard resistors. So between 100 and 220 or 200, there's no resistor, but we are getting an intermediate value of 160 ohms. So in market it's this resistor is not available, so we can't give 100 because the LED may burn off, because the more current will flows off. So what is the next option? 220. So that is the reason if you see the tutorial or Arduino main page, it's used 220 because these are the fixed values. These are the resistor values which are available in the market. Yeah, okay. 220 ohms. 100 ohms is available. 100 ohms is available. 220 is ohms available. But what we want 160 ohms, which is not available. So we can't give less resistance because it may damage LED. Yeah, okay. And as LED, yeah, see, you got it, no? Yeah, okay. Now it's Arduino uses like it's internally there, the resistance varies component to component. Tinkercad by it's 1 kilo ohm the resistor. Yeah, okay. Now, yeah, just I will stop simulation and I will write 220 and I start. You can't see that much difference. It will glow. Yeah, okay. Now let's code. Okay, it's only turning on. Then how to make it blink? Okay, I will just write digital right LED of low. Do it's going to work out? Yeah, because if I run this, it's continuously on and it will not go to delay. It will just go to delay and comes back high. So we had to give something delay, like how much time after uh, the next iteration, the next line should run. So what does delay means? Delay is a time. 1000, whatever the inside the argument inside delay function is in microseconds. Sorry, milliseconds. 1000 milliseconds is equal to 1 second. So if I start that one, if I close this, you can see. Oops, something went wrong. Let it decide. Yeah, okay. Yes, you understood. First thing LED high, afterwards wait for 1000 seconds, then LED low. Then wait for 1000 seconds, again the loop starts from the beginning. That is high. And it continues. You guys got it? Any doubts here? Okay, now I have one question. Like, can we do somewhat interesting? Why it's going? Okay, it's moving for like iterating for infinite times. Yeah, yeah, 1000 milliseconds. It's 1 second. Okay, now okay, this loop is running for infinite times. But if I want make LED to blink only for 5 times and it has to exit, it has to stop blinking. So what can I do? Guys, come on, guys. We have already done this in dive into C workshop. And if you have a programming knowledge also, you can easily say this one. Yeah, perfect. Just using logic, that is using if else statement and initializing any one variable. Like uh, just I will initialize a variable called count that initialize 0. Then I will go, just I will cut this and just if count is equal to 5, then what to do. Exit, else, do this. Yeah, indentation does not really matter in C, but to look good, I'm keeping indentation. So let's run it. 1, 2, 1 minute. Something went wrong. Yeah, count plus plus. Okay, just we are incrementing. Yeah, done. Okay, you see, like after 5 times of blinking, it stopped. Yeah, okay. Yeah, sure. 1 minute. I'll just copy this and I will ping in the Instagram chat box. Like, I'm sorry, YouTube chat box. It's a restriction. Yeah, one thing I will do after the session, I will send everything. Otherwise, I will drop in the chat box. Yeah, Teams chat box I will drop. Uh, yeah, yeah, okay. Somebody share in the WhatsApp group. Can anybody share in the WhatsApp group? Otherwise, we will do one thing. After the session, we will share this one. Yeah, okay. Tinkercad. Tinkercad. I just dropped in the chat box at 1 minute. Just go to Google and type for Tinkercad. Tinkercad. Okay, you can find it. Can I continue? Yeah, okay. Now, okay, we gone into basic thing. Now it's time for going into the somewhat 1 minute, somewhat advanced. Like, can anybody say what is motor? Hello? Is my voice is audible? Oops. Hello guys, can anybody say what is a motor? A DC motor. Is my voice is audible? Yeah, okay. Okay, DC motor it's an electronic component or electronic device which converts the electrical energy into mechanical energy. Like it rotates. There's like conversion of electrical energy into mechanical energy. So just okay, do you guys think like Arduino can program or Arduino power is sufficient to program a DC motor? Not really, right? So we use motor driver. The name suggests like motor driver. It drives the voltage. You can see this is a board and this is just M1 and M2. Each motor have two terminals. each motor have two terminals, one terminal here and bottom is another terminal. So this can be used for connection of two motors. It can drive the voltage, it can drive the uh, uh, program for motor for two motors, motor 1 and this is motor 2. Okay, and when it come to these all the things, like this is enable pin, these all the things, and it have L293D IC. This is the IC which have, because it's a microchip, it should control when it is connected to the uh, Arduino Uno, it has to transfer, it has to receive the signal and it has to give output to the device. So these pins are 5 volts and ground pin. We can give connect the external battery. So I will just yeah, it's very hard to understand here, so I will just go to the code and I will show you guys like how to connect that all the things. So just I will stop simulation. Okay, now what I need, first thing I need breadboard. Yeah, I will explain how to use a breadboard and all. One breadboard, just drag and drop here and just click. So, okay, now I want to search for more DC motor. This is a DC motor in Tinkercad, and I want, now main thing I want L293D. 293D is IC. This is motor driver. So I will connect here. Just I want to place this motor driver in middle, because in Tinkercad the whole motor driver circuit is not available. So we are using this L293D micro. This is IC. So you can, Tinkercad allows, Tinkercad says when you hover on the pin, it says like it's enable pin, it is output pin, and whatever it's there here, this is connected to internally to these things. Output pins will be connected to motor and input pins will be these other things, M2A, M2B, M1A and M2B. Okay, yeah, first of all it will be confusing, so I will explain in a clear manner how, what are these pins and how we have to connect. Okay, first thing, enable pin. Okay, this is breadboard. First I will introduce what is breadboard. Breadboard is like if you want to extend a circuit, some here these other pins are not sufficient, so I use a breadboard to which can have access to so many pins or so many ports. So here it have plus and negative. This for we can power the breadboard. Like if you power one thing, like I connect this to 5 volts. So all the pins here in this row or in here horizontally will be 5 volts, and if I take negative, just I will go and connect to ground, and all the pins here in negative column or negative row will be uh, ground, and these alternates will be 5 volts. But same thing here and left and right, but when I come to middle, these alternatives will be vertically equal. If I hover on it, you can see there are somewhat green, one minute, just zoom in, there are green color dots saying that these all have same potential. If I connect 5 volts here, all these have 5 volts. So guys, are you getting? Yeah, this is a breadboard, nothing, uh, just this is enable pin, and this is as these all have same volt, same potential, and these will be same. If I connect a wire from here, it will be connected to enable pin only. If I connect here, it will be also enable pin only. So first thing, I want to connect enable pin to 5 volts. So this is thing I will connect to 5 volts here. You can connect from here, here, or anything. If vertically everything is same. Next thing, input. Input is like we have to give instructions to the motor driver, and motor driver don't know what to do. It has to give, the instructions have been transferred from the Arduino Uno. So this thing I just want to go and connect to any sixth pin. Yeah, sixth pin. Okay, input. And what is this thing? This is output pin. So I just go and connect this output pin. I just drag this down so it will be easy for connection. I'll just go here. I just connect here output pin. But main thing I have already said, like we need a battery, we need external source because Arduino can't power everything. So I just take a 9 volts battery. I'll keep here, or I will just keep it down. Yeah, okay. Now this is ground pin. Ground pin is connected to ground. Okay. Now this is also ground pin. Two ground pins. We have to connect to ground. And another thing, we have output 2. What is output 2? Like this is the, because motor have two outputs, like we have to give two, we have to connect two terminals. That is, one terminal is already connected and this is another terminal, and this is input, because this have motor can rotate in both clockwise and anti-clockwise. So if you reverse the terminals, it will rotate in one direction. Suppose it takes clockwise. If you again reverse the terminals, it will rotate in clockwise. So we have, physically we can't do it, we can program by giving 0 1 1 0, those are the things. So this input pin, input 2 pin, will be connected to any digital pin of Arduino. I'm taking here 5. Now power pin. Power pin here is connected. We have to power to the, we have to give power to the like IC. So just I will go here and I will go and I will connect here the setting, and I connect this G and D. Here ground, and this is the circuit. And these are the things is for motor 2. As I said, like as I've already said, like L293D is used for powering what you say, two motors. So here I'm connecting only one motor, so it's not an issue. Okay, now it's time for coding. Just I want to change here. I just want to change LED. Okay, now I want a motor, like I want M1 motor terminal 1 6 is connected to 6th digital pin, and another thing is connected to 5th one. Okay, and these are also motor outputs. So M1 is output and pin mode M2 is also an output. Okay, guys, are you getting? Hello? Oops. Yeah, hello. Yeah, we have to remove it. Sorry. Yeah, okay. Now we can go ahead and type uh, digital write. We are writing now. Previously it's LED, now it's motor. One thing we are giving 1, or it we can give as high. And at the moment I'm at the same time I'm giving digital write. I'm writing M2 low. So just I will start simulation. 1 minute. There's something wrong. Which one? No, no, no. Each motor have two terminals. So for four motors, it will have what you say what you say for for two motors, it have four terminals. So each motor we have to program for two pins. Okay. First thing, let's read the error. What's the issue? It's saying that voltage pin input is 5. It's more. Okay. Input is correct, and this is also correct, and I don't. No, no, no. 9 volts. That is sufficient. Just I think we have done somewhere wrong. Power. Yeah. Okay, guys. I figure out. Just guys, take 10 minutes break. Is it okay? Just something circuit is like somewhere circuit is wrong. Okay. Let's meet at 11 o'clock. Okay. sorry, here you have uh, two terminals to the DC motor, right? Yeah, it's not exactly positive or negative. Here it's showing red and black, but it's not positive or negative. If you connect, if you give this high and this low, if you give this positive and this negative, then it will rotate in one direction. It may be clockwise or anti-clockwise. But if I want to reverse the direction, so I have to give this as negative and this as positive, so it just then it will change the direction. So for changing two terminal, programming two terminal, like shifting 1 or 0, we need two inputs. So I will just show the code. First I will run here, so you can see it's rotating in anti-clockwise, right? Hello. Yeah, it's rotating anti-clockwise, but you ask why we need to give two inputs. So if I have only one input, it will rotate in only one direction. So if I, why they did like, because for programming any robot, any car, it has to move forward, backward, and turn U-turn. So does the thing, you need to change, you need to program the two terminals. So two terminals need two inputs. So does the thing. So this is for uh, one motor input, one side. So if I change to high state, if I change to low state, if I give, I'm just altering the signals by using two inputs, two different. If I start simulation, if I close the code, oops, if I close the code, you can see it's rotating in clockwise. Yeah, okay. This is a reason to alter the to alter the potential difference between two pins. We use two input. Is this okay? Any doubt? Yeah, sure. Was the time? Did everybody came? Okay. Can guys? It's a break. I think break is over. Can I start? Yeah. Okay. Just I will make. I forgot one connection to make. That is uh, L293D. The motor driver have two power connections. One is to 9-volt battery and one is 1 is to 5 volts, which has to power the microcontrol, like this thing, motor driver itself. So the power one, this is the main thing I forgot. Just I will connect, I can connect here or wherever I want, but I want to use this pin. So positive. So for using this thing, this is connected to nothing, not even a VCC, not even ground. So I will take connections from here, this positive to here. So all pins will get all the ports will get positive, and this is negative, and this is, that's the change. Anyway, just run, it will start. And other thing, I'll just focus on why in there are two inputs. Okay, I showed for low and high, high and low. If I just keep both high, guess what happens? Focus on here. Just focus here. Yeah. What happened if I click on start simulation and here both are high? Any guess? Just guess, guys. Okay. Yeah, your voice is not clear. Can you repeat? Okay, just I will start simulation. Let's see what's going to happen. Zero is not at all moving. Any guess? Okay. Yeah, exactly correct. You are giving one here. You are giving one here. There is no potential difference. If there is no potential difference, there is no current, so it will not move. If the same thing happens if we give low and low, same thing, low and low. If the current has to flow, there should be a potential difference. So if the potential difference is not there, then it will not move. See here, the same thing happening. If I just give high, now potential difference is there, one is high and one is low, now it starts. If I reverse, direction of the motor reverses. That is why we need two input pins for controlling two terminals of output. Yeah, okay. Hope everything is clear. Yeah, it was so small, it will be confusing, but I will share the circuit diagram. I will share my a link to my Tinkercad of once after the session, and also code also. Now at the moment I will keep the code in the chat box. And yeah, anybody can share in WhatsApp group. Fine. Any doubts, guys, about how to program, about connections, about LED, about Arduino Uno? Which one? Yeah. What was? Yeah, okay. First thing, this is first thing. This is enable pin. It has to enable, and it will be connected to 5 volts. Okay. Oh, can I explain by just mouse, or I have to do the circuit again? Whichever you feel comfortable, I will do that. Yeah, okay. This is uh, enable pin 5 volts, and when this is input pin, it is like one of the input for one of the terminal, so that is connected to input will be given by Arduino, so we have to connect this to here. So this is input. I will just change the color to green, you can see here. Yeah, this is input pin and connected to 6, so we can give signals from the Arduino to the motor driver. So, and next thing is like output, whatever the signals we are coming from input to the motor driver, it will go and process, and it will send to the motor, and this terminal is controlled by this pin. Okay, I will also change this one to color. Okay, and here these are grounds. This is ground and this is ground, so I connected to ground. This is all negative. Okay. Yeah, because each thing, if you are giving because we have to internally connect to ground, and it will be done in motor driver internally, but we are using microcontroller, so this is a way we have to control. If you use a board, you can just plug in using jumper wires, but here now I'm explaining how you can use microcontroller also, like sorry, separate ICs also. Now this is output 2. Output 2 is like another motor, output for another terminal. This is setting, and subsequently beside that it will have input to control that one, and this is setting. And the similar thing, similar pins will be there opposite to, if we can control the other motor also. Yeah, okay, is it clear? Yeah, any doubts? Yeah, somebody is asking previously. Yeah, because like we have to power, this is power, external power source, but we have to give power to microcontroller. This like, sorry, this motor driver also. This is for maximum it taken for running of motors, to for motor driver to program. While programming, we have to take the voltage from the what you say, this one Arduino or any 5 volts power. There is two power sources, like two power pins. It's all internally connected, so that's why as we are not using audio like motor driver board, so we have to do all internal connections, and this all the board is made and called motor driver. Okay, yeah, next. Yeah, somebody's asking doubts, no? Okay, if everything is if there are no doubts, we can move to the next session. Any doubts, or let's continue? Yeah, okay. Now I will invite Somili to explain about the ultrasonic sensor, infrared sensor, and temperature sensor. So Somili, take the session. Yeah, I. Yeah, it's audible. Somewhat, but it's okay.
Share my screen. I hope my screen is visible to all. You might have understood the function of VCC and ground pins. We use it to give power to the sensor. We connect it to the Arduino board to give power to the sensor. Now, what is this trigger and echo pin used for? This trigger pin is responsible for triggering the sensor so that it starts generating the ultrasonic waves. And what is this echo pin used for? This receives the waves. Okay, I mean, this is responsible for determining that we have received the waves and there's an object. Okay. Now, this was the concept. Now, to know the internal logic, to write the code, we need to know some things. That is how we trigger the sensor. There's a condition for it so as to start the generation of ultrasonic waves. What is that condition? The condition is we need to trigger the sensor by keeping the trigger pin high for 10 microseconds. When we do this, then this module emits in burst of 8 cycles. Okay. After that, the echo pin waits for the trigger pin to complete the generation of the ultrasonic waves, and then it starts receiving the detection, like the waves, and it detects the object. So you need to know one more thing, that the time duration, that is the output of the sensor, is nothing but the time duration for which the echo pin stays high. Okay, so the things you need to know for writing the code part is to trigger the sensor. That is done by keeping the trigger pin high for 10 microseconds so as to generate the ultrasonic waves. And the output of the ultrasonic sensor, that is nothing but the duration, time duration, is how we get it. It is the time for which the echo pin is high. Okay, so is this clear to all of you?
Yeah.
Okay, now we'll move on to Tinkercad, do the connections, and start writing the code. Yeah. So what are the things we need? First, we need Arduino board. We'll drag and drop it. Okay. Now we need an ultrasonic sensor. So this is the module we are using, HCSR04. We'll drag and drop it here. Fine. So to give power, what we need to connect the VCC and ground pin to Arduino board. Where do we connect the VCC pin? Can anyone tell me?
VCC to 5 volts.
Yes. So we'll connect VCC pin to 5 volts. Change the color to red. Okay. And we'll connect the ground pin to ground. Okay, so we have given power to the sensor. Now we need to connect the trigger and echo pins. So just now we saw that these two pins operates on digital values, that is 1 and 0. So we will connect this to digital pins of the Arduino board. Okay, let's say we'll connect echo pin to pin number 2. Okay. And the trigger pin to say pin number 3. I hope the connections are clear.
Yeah.
Yes.
Okay. So now we start writing the code. We go to the code window. We change the blocks to text. Continue and then start writing the code over here. Two main functions that are required for writing code is, what are the functions? Tell me, quick.
Void setup and void loop.
Yes, void setup and void loop. So we'll write it. What we do in void setup, we set up everything, like we set up the connections over here. We just declare everything. We make the Arduino know that we have used your this pin as output pin, we have used your this pin as input pin. So that is the code part that we write in the void setup. So what are the things that we need to write in void setup? We need to set up the pins. Yes, pin mode. Very good. We need to declare what is the pin that we are using as an output pin, what is the pin that is we are using as input pin. We need to declare here. So we'll write pin mode. What are the two pins? One is trig pin and one is echo pin. So before using the trig pin and echo pin here, we need to do one more thing. We need to declare it before the function that we have used it to, like we have connected it to the second digital pin and the third digital pin. So first we'll declare it here. Where did we connect the trig pin to? It's in 3, right? Yeah. So we'll give 3. Done. Now we can write the setup code here. So trig pin, as I told you, trig pin is responsible for generation of ultrasonic waves. That is, the waves are transmitted from the transmitter out to the surroundings. So it has to be declared as the output pin. So here we are gonna set up as the output pin. I hope everyone is getting.
Yes.
Thank you. Yeah, we're using echo pin as the input because this pin is responsible for getting the reflected ultrasonic waves absorbed by the receiver. Okay, so we use it as the input pin. Now, one more thing now we are going to declare here is in the void setup. Our motive is here is to measure the distance between the object and the sensor, like how far the object is from the sensor. So we need to display the distance. How we will do that? We can display it in the serial monitor over here. So to start the communication with the serial monitor, we begin the serial communication here. That is done by writing serial.begin 9600. This is the default frequency for starting the serial communication. Okay, so this is our completed, we have completed writing the setup code. Now we move on to the while loop. I hope everything is clear till here. Right?
Yes.
Guys, respond. Yeah, thank you. So now we start writing the code in the void loop. So
What is
are the
that
things?
serial.begin?
Serial.begin is like we are starting the serial communication. We need to display in like the LED program. There was nothing that you needed to see because you can directly see the LED glowing, right? But how will you know that what is the distance it is measuring, the sensor? You need to see the output. So to see it, here you can see down there is a serial monitor. Can you see here? So we start communicating with the serial monitor. We transfer data and communicate with this serial monitor. So the distance that is measured by this ultrasonic sensor will be displayed here. To see that, we need to begin the serial communication. So for beginning the serial communication, this is the default frequency 9600. So by writing this line, we are beginning the serial communication with the serial monitor. Understood?
Sorry, just check the distance, right?
Sorry, pardon?
Oh, is it just so is it to check the distance? Like, is
It's
it the limit of the distance?
no, it's not the limit of the distance. This is just for when we run the code, I mean, we start the simulation, you will be seeing the result in the serial monitor. Okay, if we don't write this, then this sensor can't communicate with this serial monitor. So we won't get any output. It will measure, but how will you know that what is the distance? You need to see the value. So for knowing that value, this serial monitor displays the value that how far is the object from the sensor, and that will be displayed here. It will be clear to you when we start the simulation, but this line is just written for starting the serial communication. Okay, this is 9600 is the default frequency.
Okay.
Okay, it will be clear to you. So yeah, next is, as I told you, the sensor outputs the time duration. Okay, it outputs the time duration taken by the wave to travel the entire path from transmitter to the object and again back from object to the receiver. But our motive is to calculate the distance, right? So we need to apply a little bit of maths in the code to convert that duration into the distance. That is what is the distance between the object and the sensor. Okay, but before that, the logic we saw was to trigger the pin we need to keep the trig pin high for 10 microseconds. This is what we do for generation of ultrasonic waves. This is the required condition. So we will keep the trigger pin high for 10 microseconds. Let's write it because it's connected to digital pin. So how we write it? We write digital write trig pin high. Condition was that we need to keep it high for 10 microseconds. But as Vishnu told you earlier also, this uses the unit milliseconds. So we need to specify the unit. We will delay in microseconds. Yeah, this means that we are delaying for 10 microseconds, and then again we will set the trig pin to low. Yeah. So our generation of ultrasonic waves start. But before this, we need to write, before this part of the code, before the generation of ultrasonic waves, we need to write 2 lines of code to clear the trigger pin. Okay, so that it does not interrupt our ultrasonic wave generation. We don't know what the trigger pin is, which state it is in. So first we clear the trigger pin condition. So for that, we first make the trigger pin low for say 2 microseconds, and then we start the wave generation. This we do for avoiding errors and to make sure that our trig pin is low, and we start the ultrasonic wave generation after clearing the trig pin condition. So we write 2 lines of code here. We will make So here we are clearing the trig pin condition. We'll give a small delay of say 2 microseconds. So now we are sure that our trig pin is initially at a low state, and now we are generating the ultrasonic waves. Okay, so we are done with it. Now we need to detect object and measure the distance. How we are going to do that is, we know that the ultrasonic sensor gives the output as the time duration, the entire time duration for the ultrasonic wave travel. And that is calculated by the time during which the echo pin is set to high. Because when the echo pin starts receiving the waves, so it is automatically set to high, it receives high signal. And so we can calculate the distance by the time duration during which the echo pin stays high. So the output duration, we'll take duration is equal to, here we use a pulse in function. Okay, this is inbuilt function. This is used to get the time duration. If we write here like echo pin high. So this gives us the time duration for which the echo pin stays high. This is what is the output of the sensor. Okay, so we have used a variable duration over here. We need to declare it here. So we'll declare it. Say we'll use but our motive is to calculate the distance. So we will need another variable. We'll declare it now itself. Let's say distance. Now we will apply simple formulas to convert this time into distance. Can anyone tell me the relation between like how to convert distance, I mean time duration into distance? Distance, speed and time relation. Can anyone tell me?
Speed is equal to
To
distance
multiply
by
the
time.
time with 3 into 10 to the power 8.
Yeah, okay. So we'll look into the calculation part. See, we are using what waves? Ultrasonic waves. So the speed of the ultrasonic sound in air is 340 meter per second. But the range of this ultrasonic sensor is in centimeters. Okay, it is about 2 to 400 centimeters. So we need to change the unit. And here we are using the conditions with the time unit microseconds. We are triggering the sensor by 10 microseconds, keeping the trigger pin high. So we need to change the units. Meter should be changed to centimeter and second should be changed to microseconds. How we do that? 340 meter is equal to how much centimeter? How can we convert meter into centimeter?
Divide by 100.
Is it divide by 100 or into 100?
Multiplied by 100.
Yeah, it is multiplying by 100. So 340 into 100 and seconds to microseconds is 1 second is 10 to the power 6 microsecond. Yes. So 340 into 10 power 2 by 10 power 6 gives us this value, 0.034 centimeter per microsecond. Now we have the speed of ultrasonic sound. Yes. And what is the output that the sensor is giving to us? It is the duration. So we have the time and we have the speed. So how is the distance calculated? Time into speed. Distance will be calculated by the time taken and the speed of the ultrasonic sound in air. But here we are measuring the distance between the object and the sensor. But our wave is traveling twice the same distance. So for that reason, we need to divide the distance by 2. Okay, so this is the final output or the result we will be getting in the serial monitor. Let's see how. We'll write the code to convert the duration to distance. So we have already declared the variable distance there in the beginning. Now what it is, we are getting the time and duration variable. So we'll write duration into, what was it? 0.034, right? 0.034. But this is the distance traveled twice, so we will divide it by 2. So this value that we should get in the serial monitor once we start the simulation. But for that we need to print. If we don't print, we can't see the value. So for serial communication, we have started this, like we have written this line for beginning the serial communication. Now we need to tell the serial monitor to print the value of distance. So how we do that? We do that by writing serial.print let's say distance equal to then we'll write serial value and then serial dot println centimeter. Now we do this to print the value in the serial monitor. Now, what's the difference between serial.print and serial.println? Serial.print means, yes, was anyone speaking? Okay, can anyone tell me what is the difference between .print and .println?
Like input and output.
Sorry?
Print prints in one line and println leaves a line after printing.
Yes. That means it prints in a new line. It starts printing from a new line. So this will be printed in one line, like it should print distance equal to the distance value. Then it should print centimeter. And then it should come to the next line for printing the next value, right? So we'll check the code. We have declared trig pin and echo pin. Okay. Then we have declared the variables used in the code. For void setup, we have set up the input and output pins. We have started the serial communication. In void loop, we have first cleared the trig pin condition for making sure that no errors exist. And then we start the ultrasonic wave generation by keeping the trig pin high for 10 microseconds. And then the output of the ultrasonic sensor is given by this time for which the echo pin stays high. So we get this output from the sensor. But what is our motive? Our motive is to calculate the distance. So how we do that? By using this formula, duration into 0.034 by 2. I hope this conversion is clear to you all. And then finally, we print it in the serial monitor. So let's see whether it works or not. Start simulation. See, it's printing the distance. Can you see over here? The serial monitor, is it visible? Guys?
Yeah.
Okay. Now, how can we vary it? Just click in the sensor. Now you can see the object over here. Just see when I vary it, the values in the serial monitor change. Okay. This is how we program this. And we can measure the distance between the ultrasonic sensor and how far the object is from it. I hope this is clear. Any doubts?
No.
Okay.
No.
Thank you. So shall we move on to the next topic?
Yeah.
Good. Before moving, I'll just remove this. We'll click onto the sensor and press delete button. Do you want me to share the code with you all in the chat box?
Please put it in chat.
Yeah, I'll do that. The people who don't have access to the chat box or something, others can help by sending it to the WhatsApp group. Okay, I cleared everything for the next sensor to be explained. Okay, so now moving on to the next sensor. The next sensor in queue is the temperature sensor. So as the name suggests, you all must have known that it senses the temperature and it will display some temperature value, temperature of the surrounding. So this is how it looks like. We are using here the temperature sensor TMP36 module. How does it work? It works like the range that it measures is from minus 50 degrees Celsius to 125 degrees Celsius. This temperature sensor module measures the range of minus 50 degrees Celsius to 125 degrees Celsius value. Now it works on the diode principle, okay? Like when the temperature changes, there is a change in the voltage value. It uses the property of pins. So you can see the pinout diagram over here, the temperature sensor pinout diagram. This is same as VCC and ground, 1 and 3 pins. And this is the voltage output. The second pin is the voltage output. This is nothing but the output that the sensor gives. As we have seen in the ultrasonic sensor, it gives the output as the time duration. And we converted that time duration into distance. And now we can see here that we are getting the output, the sensor output as voltage. So here also we'll apply a little bit of maths to convert this voltage value to degrees Celsius. We'll see how to do that. And the first pin is same as plus VCC. We connect it to 5 volts, and the third pin is connected to ground. So the connection's clear?
Yeah.
Okay. So what the sensor does, it measures the small change of temperature from the surroundings, and it outputs an analog voltage value. Okay. We have seen the echo pin and the trigger pin connected to digital pins of the Arduino board because it used digital values, 1 and 0. But here, the temperature sensor gives an analog voltage value as its output. Between what range? Between 0 to 1.75 voltage value. Okay, based on this voltage value, it gives an analog output. Okay. So what we need to do is we need to change this value into analog value into voltage first, and then the voltage we will convert it to degrees Celsius. How we will do that? We will see it in a while. Before that, we'll do the connections. So we need temperature sensor. Okay. See, you can see here the TMP36 module temperature sensor. So this is power pin plus VCC. Where do we need to connect this? Tell me.
5 volts.
5
Yes. We'll connect this to 5 volts. Change the color to red, positive, and we'll connect the ground pin to ground. Change it to black. Now, the V out, as I told you, it gives an analog value. So we need to connect this pin to the analog pins of Arduino Uno board. So let's say we'll connect it to first analog pin, A0. Done with the connections? Clear to everyone?
Yes.
Good. Now we'll do the coding part. Okay. So for every code, 2 things that are like necessary. What are those? Which 2 functions?
Void setup, void loop.
Yeah. So we'll write void setup and void loop. We'll leave space for declaring the variables that we'll be using. This is the pin that is connected to analog pin A0 of the Arduino board. So we will declare it. Let's say take it as sense pin. A0. Then now, what is the output that it's reading? An analog value. We take it as INT reading. The reading that will be the output. Okay. But our motive is to convert this value into temperature. So we will require another variable let's say temp. Okay, int temp. So we are done with the declaration of, sorry, should be double, not an integer value. We are done with the declaration of the variables. Now we have to write the setup code and the main code in the void loop. So to begin with the setup code, what we need to do is we have one single pin and we have initialized it like we have the sense pin to A0. We need not specify the input pin and the output pin separately. So one line code, a single line code that we write in this void setup for this sensor is to begin the serial communication. This will begin the serial communication with the serial monitor, transfers the data, and the serial monitor will print the values. Okay. Now, beginning void loop. What it does, the sense pin, we have declared the sense pin to A0. So this pin will be responsible for reading the values. And where we are going to use it, calculate it, is the variable that we have used reading. So what we will do here, we will do that reading will get the analog values from this pin, A0. Okay. So as we used for digital pins, digital read and digital write, here we will use analog read to read the analog value. Okay. So analog read, which pin? It's A0. We are getting the analog value. Now we are we need to apply maths to convert this analog value to temperature value. How we'll do that? We'll see the calculation part. Analog value, the input that is given to us is between 0 and 1023. Here, 0 corresponds to and 1023 corresponds to 5 voltage. Now we need to convert this analog value to voltage. How do we do that? See, it is the range from 0 to 1023, between 0 to 5 volt range. So how do we convert this analog value? We are receiving an analog value. So what we'll do, we will divide it by 1024 and then multiply it by 5 volts to get the voltage value. Okay? Is it clear to everyone? Hello?
Yes.
Okay. So we'll do this first. We'll go line by line. We'll first convert this thing to voltage. Write the code over here. What we did is we have taken the variable temperature. What we'll do, we have converted the analog value to voltage. Okay. Now our motive is to display the temperature value, not the voltage value.
We have to convert the voltage into temperature, no? Not the temperature
yeah.
to voltage.
Yeah, we are taking the variable as temp. Here now, till this line, it is having the voltage value. I have taken only one variable. You want me to use separate variables? Because this is the same thing. Till this line, it is having the value in voltage. We will use the same variable and convert it into degree Celsius. Here we don't get the value in degree Celsius. This is just converting the analog value to voltage. Okay. I have used the variable temperature, but this is not giving, till this line, it is not giving the value in degrees Celsius. We'll further convert it. Is it clear now?
Reading was in temperature. Reading was temperature only, no?
Reading is not temperature, it is an analog value. This pin outputs an analog value that corresponds to the range 0 to 1.75. Okay. But the analog input that we receive from here is from 0 to 5 volt. So the analog value that corresponds to that value, 0 to 5 volts value, is 0 to 1023. I'll show the PPT. See. The analog input is between this that we receive for 0 to 5 volt range. Okay. But the sensor gives the output in voltage for 0 to 1.75 volt. This is what it is written in the third line. Till now, we have just converted the analog value that is received to the voltage value. Okay, corresponding to the 5 volts. Is it clear?
Yeah, got it. Thanks.
Yeah, thank you. So now further we have to convert. This is the one line code. I am just going line by line so that for one line we are converting, then I am writing the code. Then now again I'll move or do the further conversion and then again write the code and display it. So it will be clear to you. So see, this is the range 0 to 1.75 volts. But what is the range of the temperature sensor that is outputted in degrees Celsius is minus 50 degrees Celsius to 125 degrees Celsius, isn't it? So as we know, the sensor will output this value. For a range, what is it? From minus 50 degrees Celsius to 125 degrees Celsius, it is a range of 175 degrees Celsius, right? So this is corresponding to the sensor will output this value 0 to 1.75 volts over 175 degrees Celsius range. But what we are doing, we are not measuring the Celsius from 0 degrees Celsius to 175 degrees Celsius. We are measuring it from minus 50 degrees Celsius to 125 degrees Celsius. So we need to shift the output value such that the starting value is it corresponds to minus 50 degrees Celsius. Okay, how we do that? See.
Subtracting by 50.
Yes, exactly. We do it. It is known as subtracting the offset value. In voltage, first we can directly subtract it by 50 if we first convert it to degrees Celsius. But here the calculation I have used is the thing we saw there is for 0.01 volt corresponds to 1 degree. If the range 0 to 1.75 volts is over a range for 175 degrees Celsius, then we can conclude this that 0.01 volt is corresponding to 1 degree Celsius. Right. So to shift the initial value, we are not measuring from 0 to 175 degrees Celsius, but we are measuring it from minus 50 degrees Celsius to 125 degrees Celsius, isn't it? So we need to subtract the offset value so that we get the minimum, the lowest value from minus 50 degrees Celsius. We do that by subtracting 0.5. This would have been 50 if we have converted the voltage thing to Celsius and then subtracted. But I am subtracting the offset value in volts first and then I'll convert it to degrees Celsius. Okay? I hope it's clear. It's the same thing. Guys, please respond.
Yeah, it's clear.
Yeah. So the temperature in volts, the thing that we can calculated here, Yeah, the thing that we calculated here is nothing but we converted the analog value to voltage value. Now we have the temperature in volts. So what we do to to bring it to the original range of the temperature, we subtract the offset value. So the temperature in volts is subtracted by 0.5 volts. Now this is the value in volts. We need to convert it into degrees Celsius. So here you can see 0.01 volts correspond to 1 degree. Then can you tell me 1 volt will correspond to how much degree Celsius?
100.
Yes. So how we are going to get the temperature in degrees Celsius? We'll simply multiply it by 100. We are getting here in volts. So from this relation that 0.01 voltage corresponds to 1 degree Celsius, we can conclude that 1 voltage will correspond to 100 degrees Celsius. So the temperature in degrees Celsius will be the temperature in volts that we get from here into 100. I hope it's clear. So this is the 2-line code that we need to write for the conversion from voltage value to degree Celsius. We'll use the same variable. We'll go on temperature. What we need to do, we need to subtract the offset value. So we'll subtract it 0.5. Then what we need to do, we need to convert it to degree Celsius. That is done by multiplying it by 100. This is done. Now we have successfully converted the value, the voltage value, first the analog input to voltage and then voltage to, we have adjusted the range and then finally converted it to degree Celsius. Now we need to print the value so as to see the output. Okay, how we do that? Can anyone tell me how we will do that? What line shall we write?
Serial.print.
Yes, we'll write serial.print. Let's say we'll use temperature. And serial.print the value that is stored in the temperature variable. Okay. And then what is the unit? It is degree Celsius. So serial.print ln, we'll write ln because we want after printing degree Celsius, the serial monitor should print the next value in the next line. So we write ln over here. We'll write degree. Okay, so we are done with the code. We will verify it once. We are using the sense pin to declare it to A0 because we are connecting the V out of the temperature sensor to A0. Then we are initializing the variables that is required in the loop part of the code. Then we set up the code, that is nothing but we begin the serial communication here. Then we write the main code in while loop, that is first we take the analog reading in the reading variable. Then we convert that analog value to voltage corresponding to 5 volts. We convert it. Then that is adjusted according to the range of this temperature by subtracting the offset value. Till this line of the code, the temperature variable is having the value in volts. Now, in this line number 14 of the code, the temperature is finally converted into degrees Celsius. And then we display it in the serial monitor. We'll see how it works. Start the simulation. See, we are getting a value. what it says, it's 24.71 degrees Celsius. Now click on the temperature. Wait, let me zoom. Can you see the value? Can anyone respond?
Yeah, 25.
Okay. So
Can you please show the maximum and minimum value?
yeah, see, it's 125 degrees Celsius. It's printing somewhat 124.80, and this is minus 40. In Tinkercad, it's not the proper range of the temperature sensor, but it is between that. For like ultrasonic sensor also, the original range is from 2 to 400 centimeter, but you can see in Tinkercad it's up to 350 or something. So in Tinkercad, the lowest value is minus 40 and the highest is 125 degrees Celsius. When we vary it, you can see it in the serial monitor, the values change. So it's working. Yeah, I hope it's clear.
Yeah.
Okay. I'll share the code in the chat box. Stop simulation. Clear the serial monitor. Yeah, done. So I'll explain. Close the window. Delete the temperature sensor. Okay, so moving on to the next sensor, it is the infrared sensor. This is how it looks like. Sorry. So an infrared sensor, it is nothing but it's an electronic device that measures and detects infrared radiation in its surrounding environment. Okay, it can detect if there is an object nearby, and it can also detect the heat of the object, and it can also measure, detect the movement, how the object is moving. These are all the things that is done by the infrared sensor. For this sensor, it is not in the Tinkercad. So this sensor's use and the concept will be better explained by Vishnu in the line follower report project. So I will show the connections in the PPT and write the code in the Tinkercad, but we can't do the connections in Tinkercad because this IR sensor is not present in there. So we'll look further into the working. This infrared sensor has mainly two components, okay? One is the emitter and one is the detector. What is the emitter and the detector is? You can see these LEDs, okay? The emitter is the IR LED. This one is the IR LED, and the detector is a photodiode, okay? So the IR LED emits light in the infrared spectrum, and when it detects an object in the surroundings, it detects the object, then the light is reflected back, and that is absorbed by the photodiode. This is how the infrared sensor detects object in its surrounding. But there's an exception. If the object is in black body, then it is not possible for the infrared sensor to detect it, because black body absorbs all the infrared, it can absorb all the light radiations, and it won't reflect the light back. So the photodiode can't detect the presence of the object if it is in black body. Okay. Now, let's build a circuit. I can't do it in the Tinkercad, so we'll see it here. This is the IR sensor. And this is the Arduino Uno. What are the pins over here? We have a output pin, we have a ground pin, and we have a VCC. So VCC and ground is familiar to you. We do the connections to the Arduino board to power on this infrared sensor. And what is this output pin? Now, there is an LED in the internal structure, like normal LED. We have an infrared LED over here and a photodiode. There's an a normal LED present in the infrared sensor. So the logic that it uses is, if it detects an object in the surrounding, then that LED glows. Okay, so this output pin is responsible for that value. We get a digital value. If the LED glows, it gives 1 as the value, and if it is off, then we receive 0 as the value. So this should be connected to a digital pin because we are receiving a digital value. What value we are receiving is the glowing or non-glowing of the LED, the normal LED. Now, this also depends on the manufacturer of the IR sensor. In some IR sensors, if object is detected, then the LED is turned high. But in some IR sensors, the logic is this way, that if it detects, it is turned low. The normal LED glows throughout, but when it detects an object, then it turns off. So it varies upon the manufacturer of the IR sensor. So the concept is, we connect the VCC and ground pin to 5 volts and ground pin of Arduino board to give power to the IR LED. And we connect this out pin to a digital pin of the Arduino board to receive the status of this LED that is inside the IR sensor. Okay. So the code I'll be explaining, in it I have used the logic that if we are detecting an object, then the LED glows. Okay. We'll see the code line by line in Tinkercad to show you the connections. See, we are connecting this out pin to a digital pin, let's say 6, and we are connecting the VCC and ground to 5 volts and ground pin of the Arduino. Okay, so we'll write the code. In the code window. Till now, it must be clear to you all that we use 2 functions, that is void setup and void loop. Okay. Now, we let's say we have connected it to the IR sensor pin. Let's give it a name, IR sensor.
Can you share the picture of the connection?
Yeah, I'll do that. Let me finish writing the code. I'll share everything at the end. Okay, don't worry about that. Let's say take 2. Okay, so this is the pin that we are connecting to the digital pins. Okay, I've taken any value. Now, we saw that there is an embedded LED in the IR sensor that is responsible for letting us know whether we have detected an object or not. So it is present in the IR sensor. But to get that value and have a detection in the Arduino board, you know, Vishnu has explained you that this LED, can you see my cursor? Guys?
Yes.
Yeah, so this LED is internally connected with the 13th pin, right? So we will use that value to switch on the LED and switch off the LED, this LED, so that we can know that whether the object is detected or not. Okay, so We know that it is internally connected to which pin? 13th pin, right? We read that. Now comes to the void setup part. Here we need to define the input and the output pin. So IR sensor pin is obviously the input pin because it will receive the signal from the embedded LED in the IR sensor. Okay, and the LED here, it will be the output pin. We'll set up as the output pin because it will give us the result by glowing or switching off that whether we have detected the object or not. So that is output. So we will, what we write here, pin mode. We will set up IR sensor as input. And LED as output. Okay. So our setup is done. Now we come to the void loop. Void loop. Okay. So what we need to do, we need to sense, like we need to detect the output of that LED that is inside the IR sensor. So let's say we'll take a variable. Sense. And we will read the value of what? The IR LED present in the infrared sensor. Based on that, we need to glow the LED or switch off the LED here. Okay, so we will first take that value from the IR sensor. Okay, we need to declare it here. So here we are reading the value of that inside embedded LED in the IR sensor. Now what we need to check, this sense value is high, then we will glow the LED. That will make us know that we have detected an object. So for writing that, we need to use if statement. We will check if our sense pin is equal to 1. Okay, that means the LED inside the IR sensor is glowing. That means it has detected the object. Then we will write, or we will set our Arduino LED as high. How do we do that? We do that by digital write. We will set our Arduino LED as high. Okay. Else, if this is not the condition, if we are receiving a 0 value from the IR LED, not IR LED, the normal LED that is inside the infrared sensor, then what we are supposed to do is, we are supposed to set the LED of the Arduino board to low. How do we do that? By doing digital write LED low. Okay, so this is the code that will detect whether an object is present in the surrounding of the infrared sensor. So this logic gives you the output that if the sense pin of like the LED in the IR sensor gives us a high value, then we will turn on the LED of the Arduino board and we get the information that it has detected an object in the surrounding. Otherwise, if it senses a zero value, that is the LED of the IR sensor is in low state, then we are making this Arduino LED as low to get the information that there is no object present in the surrounding. Okay, but remember that this depends upon the manufacturer of the IR sensor. This logic can vary. In some IR sensors, it is like if it detects 1, then there's no object present in the surrounding. If it's 0, then there's an object present in the surrounding. Okay, so this is the logic, simple logic, and this IR sensor will be responsible or will be used in the line following robot concept. I'll just copy paste the code. Do you guys have any doubts?
Yeah, at the end of the session, can you explain the connections of motor driver again?
Okay, sure. I think Vishnu can take it up. So thank you guys. This was my part. I invite Vishnu now to take over the session for the line following report. Hope you guys understood everything.
Yeah.
Thank you so much. Over to you, Vishnu.
No, no problem.
Oops. 1 minute. Yeah, hello. Is it visible? Yeah. First of all, going to line follow robot, because yeah, you guys have learned what is infrared sensor, what is motor, and everything. Now it's time to uh, combine everything and make some robot project. So before going to the deep into the technical details, so I want to know what is line follow robot. Can anybody say what is line follow robot? Not really. Yeah, yeah, it's perfect. Perfect answer. The robot is powered with two motors or four motors, whatever the motors it may be, and it follows the line, which is in color of black color. So just think like which sensor can we use here? Yeah, perfect. Infrared sensor, because infrared sensor can't detect black color. So we are using that as advantage and making a line follower robot. And this is a working principle as Somili already explained. I just give a small intro about the line follower like infrared. Emits the line IR light and reflected light will be absorbed. And do you just remember black body radiation from your I think 12th class? So whatever the light which will be fall or the fall on the black body, it will be absorbed and it will not allow any light, whatever the light it may be, to escape from it. So that is the principle we are using by infrared sensor to detect the black colored object. If the black colored object falls comes in front of IR sensor, it will the receiver will not receive any signals. What is the word? Yeah, receiver will not receive any IR line. So if it is other than black color, it surely receives and detects there is a object or there is other color. And to detect that, it the line follower in line follower robot, whatever the colors it may be, it will surely reflect. Just imagine this is a surface and this is a black color line and everything is normal color. So robot is kept here, and if the sensor detects this color, this black color line, it will not receive anything. So it shows 1 or 0 depending on the manufacturer. Maximum when I build a line follower robot, it shows 1 if it is a black color. If it does not receive any light, it shows 1. If this all the things is normal, it is not black color. So if the sensor is here, it emits the light and it receives the light. So emitting and receiving happens. So it gives 0, which signifies that the sensor is receiving. By this way, the wheels, the motor, all the motors will be adjusted and follows the line. This is called line follower robot. Okay. First thing, how to working. First, the input from the sensors. This is IR sensor, and from the whatever the input is given from the IR sensor will be transmitted to Arduino. The IR sensor gives the whatever the data. It may be only 1 or 0. 1 or 0. Based on this, Arduino will process and send the signals to the motor driver based on the logic which we built in IDE. It may be we will quote like if data read is 1, then do this. If data read is 0, do this. So based on that, it sends the signals to the motor driver, and motor driver send the signals to two motors, and motor driver is L293D. Okay, this is a way perfect combination from the whatever the input is sensed by the Arduino, like whatever the input sensed by the sensors will be transmitted to Arduino, and it process and it understand what to do according to the if else statement logic. Then it gives instructions to the motor driver and it will perform. This is the line follower robot, and this is the major whatever the robotic competition, major competition will conduct a competition on line follower robot. It may be in any tech fest or any national wide event or world robotic challenge also. Line follower robot competition will be there based on fastest line follower robot. So that is why we are discussing here, and let's move ahead. First thing, this is what I said, this is a black line. So right sensor and left sensor. Now I'm doing only two sensors. One is right, one is left. Okay, if left sensor and right sensor reads 0, 0 means there is no black line. Then the Arduino will sense like if the left sensor is equal to 0 and right sensor is equal to 0, then what should it do? Then activate two motors. Two motors should move in only one direction. That is, both motors should move in clockwise or anti-clockwise. Not in one in anti-clockwise, not one in clockwise, because when you are doing it differs. So when you are moving forward, it has to move in clockwise. Both motors. So it will rotate. This is left motor and this is right motor. So both motors will move forward and it will not turn. Okay, the same thing I will code here in Tinkercad. 1 minute. Yeah, Tinkercad. So this is motor, what we have done. So here we are using two motors. So just search for other motor, or you can just click on here you can just control what you say, control C and control V to paste this one. So I can just set as this as left motor, just left motor, and this as right motor. Okay, are you guys are getting what I'm saying? Am I going too fast? Yeah, yeah, okay. And I will explain the connections once again, like because I will not remove these all the connections, because it is similar way I am connecting this motor. So here it is, there are two power pins. One is at here, power 1, and other is at this one. This is the thing. Okay, here, power 2, and start here and here. We are powering, and now it's go for this pin, enable pin. You know, enable pin is connected for 5 volts. So here it's everything is same, so I can just connect here. Okay, just this is the enable pin. I want to connect to 5 volts. I'm connecting, and this is input pin. What we have to give, we have to code the terminals, like with here. Here I have 1 minute. I should show here. I'm connecting parallelly to here. Whatever the 5 volts here, this 5 volts pin is connected to Arduino. I'm transferring the same thing and connecting to here. So whatever I'm connecting, all the this horizontal pins, all the horizontal pin have 5 volts, and this is negative. I'm connecting from here. This is connected to GNT. So all the things, all the ports, like all the sockets here gets ground. So you can see, like when I'm hovering on over the mouse on here, you can see all are turning green. Like Tinkercad is showing like this all is GNT. This all negative. Okay, and but when it come to here internal thing, it is vertically same. Like that's why I'm using, I can connect from, not from here, I can connect from here also, does not make any difference. Okay, you got it? Hello? Yeah, okay. Next thing is input. Like we want to control these things. I want to change, I want to program whether it may be 1 or 0 based on infrared sensor input. So I just go ahead and connect this one to any of the pins, like I connect to 10th one. Okay, simultaneously I will code here, and I will now I have motor 3 is connected to 10 and motor 4 is connected to 11. Let's connect to motor to 11. Oh, which one? This is output. So this is output. So I just take here. Output should output means we have to connect to the motor. So let's go and connect it to the motor. It may be whatever the terminal is not an issue. Output is completed. Now ground. Let's connect this to the ground and ground. This also will be ground. Now it's time for output 4. Output 4, like we have two terminals. One terminal we have given, and it's time for second terminal. Let's go and connect to here. Okay, if you are not seeing, 1 minute, I will just make it more visible. Yeah, okay, it's connected. Now next pin will be input pin. Like this pin we have already given as input to here, like 10th pin. Now we have to program the other pin which we connected, the motor pin number 4, M4. So it will be connected to 11th pin as we programmed. Okay, now it's time for giving pin modes. I just want to just copy these things and I want to paste it here. So M3, yeah, battery be connected. Like this is a previous circuit, this is not entirely new. Battery is connected this side. this power pin. Huh? This terminal is batteries is 1 minute. I will just change the color to red and black. Yeah. This terminal of the battery is connected to power 2 pin. Okay, if you're if it is in Arduino, like if it is in motor driver, you will connect here. This is 5. Here you have to connect 9 volts battery, and this is M1. Like this is the output pins for the motor. What you guys see here, M1 and M2. And when you come to what you say this one, these are input pins connected to Arduino. These are the things. Okay, it's everything is clear. And it's power 1 and power 2. Power 2 is connected to 5 volts, and power 1 is connected to power 1 is connected to 5 volts, and power 2 is connected to uh, what you say battery, and this battery negative terminal is connected to ground. Okay, and let's go. I think maximum every connection is completed. Just a simulation. Just see everything is proper or not. Is there any issue? Okay, something gone wrong. Input is higher. Okay. Enable pin is connected to 5 volts. Okay. And this is circuit 1 minute. I haven't returned this one. And other thing, we need IR sensors. So we don't have IR, as Omili said, we don't have any IR sensor in Arduino, like sorry, in Tinkercad. So I just explained by coding. Suppose 1 minute, I just go to the PPT. It will be so easy to understand. Oops. Okay, here not this. Okay, first I will code for this one. Left sensor and right sensor both reads. Both are not on what you say black line, so it has to move forward. So first thing, I will take pin mode, and I will also declare this one. First thing, I have to declare LIR, like just for signifying left IR sensor. That will be connected to what is it? Just a second pin, and right IR sensor, it will be connected to third pin. So I'm not saying in connections. I just showed the connections of that, and as IR sensor is not available, so I just explained by code. So first thing, okay, we initialize that one, but what the IR sensor is actually doing? They are giving input. So input, both are inputs. So pin mode RIR, comma input. Okay, it's everything is fine. And serial, to begin serial connection, serial or begin, and it is all the data transmission, the serial transmission, the data will be transferred by 9600 hertz of frequency. This is what is signifying. Begin the serial communication with 9600 frequency. Now let's see. Now both sensors are not on black line, so black line is in the middle. So first thing, I just initialize something to read that. I want to get the value from the sensor. First thing, it may be 0 or 1, so we need to store that one. So I left digital read, right digital read. Okay, just signify left digital read and right digital read. So I just see LDR is like digital read of what left sensor, left IR sensor. So whatever it reads, so it may be, if it detects on the black line, it shows one value. If it's not on the black line, it shows another value. It may be 1 or 0. Now we are at this moment we are considering, if it's on the black line, it shows 1. If it is not on the black line, it shows 0. That is what the LDR will have. It stores either 1 or 0. And RDR also same thing. RDR also digital. We are reading that. Now we are not writing anything. We are reading from the sensor. So I think the inbuilt functions are named according to the what it actually do. Now the case comes using if-else statements. If the sensor is in middle, if the black line is in the middle of two sensors, what happens? If LDR equal to what we thought, if it's not on the, yeah, both will be 0, and RDR is equal to 0. Okay, now what I have to do, I have to rotate the motor. So it will be like digital write m1 comma high. I can write high or I can write just 1 for representing high. So I have already discussed about high, so let's do differently. Digital write m2 comma 0. So there is a potential difference, it will rotate. Other thing, there's another motor, it has to rotate simultaneously. M3 comma 1 and digital write M4 comma 0. So both will rotate in same direction. If you, in case they are rotating in different direction, just change the terminals, just switch the terminals here, the setting, because there's no sign for on the DC motor for the clockwise or anti-clockwise. So if you're feeling they're rotating in different directions, so you can change the connection or you can just swap the values here. Okay, are you getting, guys? Yeah, if motor 1 terminal we set to 1 and motor 2, it's like in motor 1 only, M1 is set to 1, means this one is set to 1, either of the one, this one is 1, another is 0, so it will rotate in one direction. Same thing, it will rotate in the same direction. If two motors rotate in the same direction, then it moves forward. Just some imagination, like if the motor moves in one direction clockwise, and if another motor rotate in also clockwise, it will move forward. So this is what we are having, this moving forward, and it will not touch the black line. But in case if the left sensor is on the black line, and what should it do? It should turn left to overcome on the black line, so it will move towards left. So to make sure that black line will be in the middle of the two sensors, it will be between two sensors for whatever for all the path. So what happens, then it has to do it, it has to stop this motor, it has to stop the left motor will be both, M1 will be 1 and M2 will be 1, or M2 will be 1, or M1 will be 0 or M2 will be 0. There will be no potential difference, so no current, so this left motor will stop running, so the right motor will move, so that it will turn like this. If the left motor is stopped and right motor is moving, it moves towards left. That is what we have to code. Else if LDR is equal to 1, left motor is reading 1, and RDR is 0. Then what happened? Digital write m1 comma 1, digital write m2 comma 1, or you can just take 0, not just m1 m2 are for left motor, m3 m4 for right motor. So now remaining things will go as usual, it moves forward only. M3 is 1 and digital write m4 is 0, it moves forward, so it can turn towards left, so it can overcome it will make sure that the black line will be say middle for all the time of the path. So next thing, if right sensor is on the black line, same thing, it will right motor will stop running and left motor will continue, so the robot will turn like this. And just opposite condition of here, just I will copy this condition and I will paste here, just swapping the cases. It will be 0 or 1 and it will stop running, the right motor will stop running. So guys, say that what is the final case we have. We got first thing, we got 0 0, we got 1 0, that is like 1 minute, left sensor right sensor, and we got both on the not on the black line. Next thing, left is on the black line and right is outside the black line. Next, right is on the black line. And what is the last condition? No black line means this is a no black line condition. Both are this is no black line condition, both sensors not on black line. Now we have the condition only remaining is both on black line. Yeah, okay. Previously who replied? You said no black line or both black line? Yeah, okay. Yeah, okay. Yeah, this condition will be same for this one because both sensors will are sensing there is no black line. Now we completed no black line, one black line or like left and black line on the right, and now we are remaining with black line on both. So that is this condition. So what I need to do? Just I want to do nothing, go forward. So just LDR is equal to 1 and RDR is equal to 1. So what I want, digital write of M1 will be 1 and digital write of M2 will be 0, like one motor moves forward, and digital write of M3 will be 1, and it's the same condition of first if statement. Just do nothing and move forward. This is the thing. If you want to see what's really happening, just you can click serial dot print ln. I want a new line or LDR, and before that I want just serial dot print LDR. So both will be in same line. Now serial dot print RDR and finally serial dot print ln RDR. Just I will keep this one so it will look better. Hope you guys are getting. Okay, is any doubt? This is the code. I will just copy this one and paste. Where is this? Yeah, paste in the chat box. One minute. Line follower robot code. Okay. Any doubts, guys? And by this, the line follow robot is completed. Just simple playing with if-else statements, whatever we got, and making the robot to move left or right. And you can do one other thing, like if both all like if the 1 minute, if you get a both black line, you can keep that as a dead line. So you can say the robot to U-turn. How can you make U-turn the robot? Suppose if there is no black line here, so this is a dead end. So if there is no point of moving forward, so just do what you have to do. One thing, just rotate rotate one motor in clockwise, one motor in anti-clockwise, then the motor will just rotate. Yeah, okay. Otherwise you can do one thing, continuously start the right motor and stop the left motor or anything, it moves the same. But the main problem, it moves away from the path, so it's better to make this motor anti-clockwise and this is a clockwise. For U-turn, motor one is anti-clock or anything clockwise, or this will be clock, just in opposite direction, so it will move. And open for doubts, guys. Sorry for the handwriting. Writing on the screen is. Yeah, yeah, it's there because I have also gone for the. I'm also part of the team for the robotic, like line follow robot for IIT Hyderabad Tech Fest. So to make the line follow robot fast, the main thing, if you make just I want to just open. If you want to make line follow robot fast, then you have to make sure you okay, you can use high motors, high RPM motors, but there are two problems. Problem one is like battery. If you use high RPM motors, it consumes more power, so it will eat all your battery, it will drain all your battery. That is the main thing. And also other thing uh, is like the sensors should be so sensitive to change if it is moving so fast. Suppose suddenly a straight 90 degrees turn, and in our competition they given a turn like this, robot has to move here and it has to turn in this direction. So if its robot is moving so fast, sensors should identify this turn and immediately it has to respond, otherwise it will move out of the path. So if there is some advantage, there is some disadvantage, so you have to make sure everything will everything work on, like they will work with perfect coordination. And you have to choose what is a specific RPM and what is a battery, and you have to consider the sensors also. So yeah, that's why first research, then analyze, later create. Because when you're doing the project, there are a lot of things to take consideration. You can directly make this fast, but battery and sensor sensitivities plays a major role. Just think you go all you kept a robot in robotic competition, and it's suddenly in the middle of the part, it battery got drained out. It does not look good, no? So you'll be out of the competition. And if the okay, you got battery good and high RPM, but if you have sensor sensitivity is very low, like it due to that high RPM, it can't have time to detect this path. Due to that RPM, it crosses it more outside of the path. And one thing, there are so many IR sensors. One is IR array is there, array of sensor, like so many IR sensors will be set here, and you can connect to Arduino. It is placed here as array. Let me touch any empty space, empty diagram. Yeah, it will be placed here. So there are so many things, so many factors to consider to make the robot to move fast. That is to make so much accurate. So that is why we need to research on that. We need to analyze. Then we start implementing. And also after implementing, also there is some other problems will arise. So we need to solve that one. I think you got it. Yeah, okay. Okay, guys, like how is the session? And later we will, after this session, uh, we'll update about the recruitment process. And we said like first we'll give the knowledge of C programming. Then once the knowledge of C, you get the knowledge of C programming, and you can easily understand Arduino programming. Is it true or not? Yeah, if we start C programming at this session only, it will be so mess up. So that is why we plan C programming, then we go on Arduino, then now it's time for our recruitment process. And all the details will be announced about the recruitment process, because yeah, recruitment process for the robotic club. Because as of now we can't make any decision, because we don't know how many members are actually interested or will participate in recruitment process. So based on the strength, we will let you guys know what is the recruitment process actually, and how many rounds it will going to conduct. Yeah, okay. And future events is like there's in this event semester, you guys, Python is open for all the members of RVATM, and IoT. IoT will be in July, and Python it may be or June, based on the academic schedule. It is all the things after recruitment process. And if you guys want to join, you're welcome to join, because it's not restricted for robotic club only, open for everybody. And this is a plan planning for the event semester. In middle, some Phoenix talks, some interactive talks will be there, because this is online, and some projects and research team will go ahead after recruitment. No, no, no. First in TechFest, I will say like one of the competition is line follow robot, mainly because there are so many set of competition. One thing will in IIT Hyderabad TechFest, it is line follower. One is there, and that measures on how fast which robot will complete the part first in less interval of time. It is a winner. Other thing is like quadcopter challenge. It's a drone, so there will be so many obstacles. Drone has to follow the circles, and it has to go down, and it has to land perfectly. So this is one. And robot soccer, it is wide robot, no need of Arduino. It's just like based on your control, playing like Arduino, there will be other robot competing with you, just playing soccer. So it all depends on the strength of the robot, and your skills of handling the robot. And other thing is like robo war, like robots uh, uh, will do a wrestling match. So new idea, it's like not in the competition, it will be one thing like innovation. Some of, I don't think every tech fest will add this one, because like they can't actually decide who is the winner, because somebody will do one drone, somebody will be do one like a robot terrestrial thing. So it is very hard to compare and give marks. Suppose a drone is there and it competition is like normal robot, at land robot is a car or anything, but we can't compare these two things, no. So that is the main issue.